We'll proceed in Jacobian in calculus. We'll proceed in cross Jacobian in calculus. So whatever the we are discussing about the Jacobian, this is our version. So it's not available in any of the book, and Jacobian is considered as one of the most advanced topic in calculus. So this much advanced topic in calculus, generally it is not available in any of the book. So people would refer the videos that we are kind of placing, we are putting, or we are thinking of writing a book on advanced calculus or commercial calculus. So the concept is that we talked about cross Jacobian while calculating the volume of the cone, cross Jacobian while calculating the surface area surface area of the cone, and cross Jacobian in calculating the volume of the sphere. Cross Jacobian while cross Jacobian while calculating the cross Jacobian while calculating the surface area of a sphere, that is pending, much awaited, thrilling. We have talked about it. Calculation of the surface area of a sphere through cross Jacobian. What are the different kind of Jacobians are? Cross Jacobian, partial Jacobian, and full Jacobian. Generally, in the books, mainly only two kinds are three. One kind is available: full Jacobian, cross Jacobian, partial Jacobian is our version. Because partial Jacobian, especially if someone is able to mix with someone is able to adapt in partial Jacobian, then it makes the complexity at least one level down. If I have dx dy, then only one is required. If I have dx dy dz, probably two or one is required. It make the simple extremely, it made the problem extremely simple, easy. Partial Jacobian, okay, cross Jacobian. Anyway, we have already calculated volume of a cone through cross Jacobian, and we found it that it is pi r square h by 3. Actually, I did not get time to see in the book if this is correct. Anyway, we will try to validate it through full Jacobian. We can calculate volume of a sphere through full Jacobian. Through cross Jacobian, volume of a cone through full Jacobian, cross Jacobian, and partial Jacobian. I believe we tried only through cross Jacobian. We will go to the cross Jacobian while calculating the surface area of a sphere. That is something that is very interesting. But anyway, let's validate the volume of a cone through full Jacobian that is available in the book. So, what is the volume of a cone through full Jacobian? What is the equation of a volume? Volume of any surface, if this is xy plane, if this is x-axis, this is y-axis, and this is z-axis, this is x-axis, this is y-axis, and this is z-axis. If that is the same, then this is xy plane, this is the surface, that is z. If I calculate integration of the surface along xy plane, it gives the volume underneath it full. From here, whatever volume it is making, that volume till it is touching the surface. When we calculate the integration, what is the limit we take? We limit two-dimensional we take, and whatever the intersection we see on the xy plane, that intersection region is the region of the integration. So that intersection region is the region of the integration. Any integration has three items. One is limit, one is integrand, and one is differential. So limit, when we calculate the volume, then limit is xy plane region. the region on the xy plane above which the surface lies. So if this is the surface and this is xy plane, the surface will go and sit on top of xy plane. Whatever the intersection we are seeing on the xy plane, this is the region of the limit in the integration. fxy dxy plane is the formula for volume calculation. fxy dxy plane. So what is fxy? What is z of the cone? dxy plane, dx dy. And limit is if there I really have a cone. Repeatedly I am showing. So this is a part of a cone. This is earthen. This is called earthen material made up of the soil, earthen material. And this is typically a cup, and you can drink tea and coffee. Anyway, I don't drink tea and coffee. So you can drink tea and coffee, or you can drink ghee, that is called ghee in India, or melted butter. I believe that would be the perfect English for it. And then you can enjoy it, whatever, everything you enjoy it, whatever suits you. You can drink milk also, you can drink tea, coffee, all are enjoyable, whatever you enjoy. I don't drink tea and coffee anyway. Okay, so anyway, I don't drink butter, or don't eat butter or ghee also. Okay, so now if this is a kind of this is a earthen material and this is a cone. So if this is a cone, if this is a cone, then this is a cut cone. Cone is cut. Okay, means this, if it, the way it is going like this and it proceeds like this, then it will form a cone. It is a cross section of a cone. The original cone, let height of the cone is h, small h. This height is z at which there is a cross section. Base radius is a. This radius is r, small a. This height is z. Full height of the cone is h. What is the volume of the cone? That is under question mark. Okay, now if we see closely, then this is radius a. Okay, this is the circumference. This is the circumference of the circle that falls on xy plane. So region over which we calculate the integration. Okay, so region over which we calculate the integration, if this falls on xy plane, that region is a circular region. It's a region, it's not a perimeter we are talking, full circular region, thick. That is pi r square. The formula of the area is full region. So full circular region, and fxy dxy plane is the volume of the sphere, where fxy is a z, that is the surface area of the volume of sphere, cone, surface area of the cone. What is fxy? What is z? So if I have xy plane, this is circular region, intersection on the xy plane. If I take this circular region on xy plane, I take any x comma y. Against each x comma y, there is a function fxy, Python function. X and y are parameter to the function. If I take any xy function on the xy plane, then if I take z on the xy plane, I mean there is a circular region. There is a circular region inside this circular region, because this surface falls and make intersection on the circular region. I have to take xy only inside the circular region and boundary, not outside it. That's why the integration region is. If I take any x comma y, apply on the function fxy, it will result in one numeric value, that is the height. If I keep taking x and y and all the height point, if I connect, it becomes surface like this, conical surface. What is it? Anyone would be amazed now. Boss, tell me, what is your magic function that if I place any x comma y and you give me one height, right? The way you said. This is a Python function. Inside the Python function, you pass x comma y, it returns a number. Pass another x comma y, returns a number. Make sure that x comma y, the coordinate of x comma y, must reside inside a circle of radius a. That circle is this circle. That one. That don't take go outside. Now keep supplying this x comma y to Python function. It will return the one value. That value, if you take as a height from the xy plane, if you collect all the value, it becomes like this. Amazing, man. What is that function is? Okay, that function is that if this is a, if this is a, this radius is a, radius is r, and this is height h, and this is z. Okay, then it results in some. Oops, then it results in like this. This is slant height. This is the height. This is the slant height. Okay, it results in like this. So this is radius a, then this is the height of the cone. If this is radius a, then this is height of the cone. This is the origin. This is the origin. Or if I take this side, then this is the slant of the cone. And this is the height of the cone. I made a cross section at this point. This height is z. This radius, small radius is r. Now a by h is same as r by this height, because this forms a triangle. If this is a theta, then tan theta is constant. Either you take this by this or this by this. So a by h is same as r by this height. If this height is h and here cross section, this height is z, this height is h minus z. So a by h equal to r by h minus a. A by h, a by h equal to r by h minus z. That is the case, h minus z equal to h by a into r. Z equal to h minus z. Z equal to h minus h by a into r. That is z, where r is a square root of x square plus y square plus x square plus y square square root. How it is like that? Anyone would ask. Now, if this radius, base radius is a and cross sectional radius is r, then consider this is the r. Now this r would rotate full 2 pi degree on this circle. If it rotates, this is x axis, this is y axis. If this rotates little bit and make angle theta, then r cos theta is x at that moment, because x and y are variable. R is variable, z is variable, a is constant, h is constant. I have to find volume in terms of a and h, not in terms of r and z, whatever. Now, x equal to r cos theta, y equal to r sin theta, and z equal to z. This is typically cylindrical coordinate system. Anyway, now we have to find the volume as per the traditional Jacobian. Full Jacobian, traditional Jacobian. Now integration over a region that is circular. Integration over a region that is circular. And then fxy dxy plane. Fxy z equal to h minus h by a r. And then dx dy. This is the equation. Now, what about full Jacobian? Full Jacobian means now dxy plane will get transformed into theta r plane. This is typical example. Now dxy I can write as dxy by d theta into d theta. So d theta is d theta dr. This is what you get in the extra, that is called Jacobian, dxy by d theta r. This is because the relationship between x and r theta, y and r theta, x and r theta, y and r theta is not straightforward. It is not linear. X equal to r cos theta, y equal to r sin theta. It is really some maze kind of some non-linear, polynomial, something trigonometric, something cryptic. In that way, the transformation, this is called transformation matrix that will come into the picture, which will transform x dxy to d theta r. We cannot write dxy equal to d theta r plane. Then dx dy will be replaced by d theta dr. We have to add one matrix, that is Jacobian. that is dxy by d theta r. We have demonstrated many times dxy by d theta r. So, if this is xy plane and this is fxy z value is dependent upon xy plane. If this is xy plane, then this is d theta, this is theta r plane. Now xy is dependent upon theta r. Three components are coming into the picture. Z value fxy is dependent upon xy plane and xy plane is dependent upon theta r. Okay. Now z equal to fxy. Z equal to h by minus h by a r or square root of x square plus y square. Now x, y and theta r. X equal to r cos theta, y equal to r sin theta dependent. Now where is the circle? Circle is on xy plane. Circle is not on the theta r plane. Theta r plane there is a rectangle. The aim of any integration, not single dimension, dual dimension. Single dimension makes sure that along which we are calculating the limit is straight line, and in two dimensional make sure the limit region is rectangular so that x and y would be independent of each other. It should be rectangular. If it is limit is a cubical region, means three dimensional, make sure that it is a cubical. It should not be a spherical and conical, the integration region. That's why it becomes complex. If it is a rectangular region, then both limit would be, typically it would be a numeric. Now what is the limit here if you are calculating the volume? It is a circular region, right? X is minus a to a and y is minus a square root of a square minus x square to a square root of a square minus x square. See the y. Y is not numeric. If it was a rectangular region, y would have been numeric. Then it would be easy, straightforward. Now, tell me, sir, where it is numeric? It is numeric in theta r plane. That's why we are taking theta r plane. Theta r plane, it is a rectangle. That rectangle is getting mapped like a circle in xy plane. Now, we are calculating fxy dxy plane. Dxy plane can be written as dxy by d theta r into d theta r. So d theta r is d theta dr. Dxy by d theta r is Jacobian. Dxy means area, area in xy. D theta r is area in d theta plane. Now if I make one unit of change in d theta plane area, how many unit of change it is making in xy plane? That is dxy by d theta r. That is the Jacobian. Now if we have a rectangle, if we have a rectangle in theta r plane, this rectangle is mapped into a circle in xy plane. If I make one unit of change in this area in theta r plane, either it grows or shrinks, how much unit of change it makes in the circular region in xy plane, dxy plane by d theta r plane. Okay. Now we have seen many times the surface area that we calculate. Like if it is xy plane and there is a surface here, and if I take any point P on the surface x, y, z, then position vector is xi plus yj plus zk. dp by dx cross dp by dy. P is a position vector. Position vector of any point P on the surface. If this is xy plane and this is the surface, if this is a position vector P, then position vector P of this coordinate x comma y comma z is xi plus yj plus zk. dp by dx cross dp by dy is nothing but d surface area by dxy plane. dp by dx cross dp by dy. Same thing we are trying right here. Now we have theta r dxy, or consider this is theta r, then above it xy. So earlier it was xy, above it was z. Now here it is theta r, this is xy. If I take any point P here and dp by d theta cross dp by dr is nothing but d surface area on xy by d surface area on theta r. This is what we want. dxy by d theta r. Actually dxy by d theta is nothing but there is, if I take any point P on xy, dp by d theta cross dp by dr. So P, this is our calculation. Very easy. So please support us. Plus 919483160610. This is telephone number. Plus 91 is India country code. And then 94831600610. 94831600610. Now we are in phase to calculate the Jacobian. So dp by d theta cross dp by dr, and whatever the magnitude comes, and d theta dr. What is p? Xi plus yj. X dx by d theta I plus dy by d theta j cross dy dx by dr cross d theta by dy by dr j. This is the cross product dp by d theta cross dp by dr. So that is nothing but dxi dx by d theta I plus dy by d theta j cross dx by dri plus dy by drj. What is x? X is r cos theta. What is y? That is r sin theta. Now, if we calculate this cross product, it will give r. This is very famous. I need not calculate the metric. Everyone knows it. That xy coordinate system to the polar coordinate system, that is theta r. Someone calculate the Jacobian, it becomes r. Now, r d theta dr. R d theta dr. Or someone can simply say, if you take a small rectangle area on xy plane, then it is dx dy. On xy plane, if you draw a circle and take a small area in the circular fashion in the polar coordinate, then one is dr and another is, if 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 this is r and it goes like this in a circular fashion, if I take a small arc where theta angle is d theta and the length of the this side length is dr and arc is angle is d theta, so arc is r d theta. If this is the r, then this is dr. If this is the arc area we are taking, then this is dr and this is r d theta. R d theta dr. Same thing we are getting through Jacobian r d theta dr. What is z equal to h minus h by a r? Okay, it is in r only. This is what we want. So very nice. Otherwise, in Cartesian coordinate, it was h minus h by a square root of x square plus y square. That is r. Very nice. Now we have to integrate h minus h by a. H minus h by a r. If we calculate this integration with respect to r dr, r will come inside and it will do the magic. Now hr minus h by a r square. There we have to calculate the integration. hr is hr square by 2 and h by a r square is h by a r to the power 3 by 3. Now integration y is minus a square root of a square minus x square to plus a square root of a square minus x square, and x is minus a to a. Okay, now the circular region, go on. Okay, anyway, we are calculating for this circular region, okay, the integration over this circular region that falls on xy plane, The circular region x is minus a to a and y is minus a square root of a square minus x square to plus a square root of a square minus x square. Let's calculate only half of it, not below it, only half portion above it. If that is the case, then y is from 0 to a square root of a square minus x square. Volume, I can multiply it by 2 because they are congruent. So 0 to a square root of a square minus x square. When y equal to r sine theta, when y is 0, r is 0. When y equal to square root of a square minus x square, y square plus x square equal to a square. Now y is r sine theta, x is r cos theta, r square sine square theta plus r square cos square theta equal to a square, r equal to a, 0 to a, 0 to a. Okay, now let's start. Here the integration is h r square by 2 minus h by a r to the power 3 by 3. 0 means gone. And then first is 0 to a. Okay, so a, if I substitute, then it becomes h h a square by 2 minus h by a to the power 3 by 3. A gone. H a square by 3. Here h a square by 2 minus h a square by 3. So if I settle it, it becomes h a square by 6. H a square by 6. Okay. Now this is for the semicircle above it. Okay. Now x is minus a to a. If x is minus a to a, x equal to r cos theta, y equal to r sine theta. Then tan theta equal to y by x. Theta equal to, now we are trying for theta, r we have done. So dr is over, d theta remain there in the differential part. Now here x, y by x, tan y by x equal to tan theta. Theta equal to tan inverse y by x. Now I can take minus a to a. Let's take 0 to a, not minus a to a, not minus a to a, 0 to a. Now we are calculating for only one quadrant. First we were calculating for top half, now only one quadrant. Then we have to multiply by 4. So one quadrant 0 to a. When x is 0, y is 0, tan inverse 0 by 0, anything by 0 means infinite, not defined. In that case, theta is 90 degree. Theta is 90 degree. Now when x is a comma 0, y is 0, then it is 0 by a, 0. Tan inverse 0 is 0. Pi by 2 to 0. Pi by 2, pi by 2 to 0. That is the limit. Now we have got integration in a square, pi a square, pi a square by 6 d theta. Now d theta we can integrate, it becomes theta. Theta pi by 2 to 0. If I don't take the minus sign, theta pi by 2 to 0 means pi by 2. It becomes pi by 2. Pi a square h by 12. Pi a square h by 12. I have to multiply it by 4 the way I did in the last session also. Pi a square h by 3 is the volume of the cone. So the volume of the cone is pi a square h by 3. So with the full Jacobian also we tried, or if we did with the kind of polar coordinate system, directly I can take radius as 0 to a and theta 0 to 2 pi. Simple. 0 to 2 pi and 0 to a, full plane, it gives me the full volume. Then h, then 0 to a if I take, then anyway it will be like this only, that is h a square by 6. H a square by 6, 0 to a. But if I take here 2 pi, then multiplied by 2 pi, it becomes h a square pi h a square by 3. That is the volume. Okay, someone can try partial Jacobian to calculate the, I am taking long so that it will be fixed, that partial Jacobian, cross Jacobian, and then full Jacobian. That is traditionally Jacobian. They have some real sense. Someone can try partial Jacobian to calculate the volume of a cone. Partial Jacobian means we don't have to take theta and r, only one we will take, like dy. Okay, it is tempting to go ahead, but it is long, it would be long. Please support us plus 91 is India country code 94831606110. Okay, so we will see the volume of a cone with the partial Jacobian.